So now we're going to review how to do a two-sample t-test for the difference in means, all right? A volunteer sample of 100 area high school seniors was used to evaluate a new speed reading program. Each student was randomly assigned to one of two methods of speed reading instruction, the standard method or the new speed reading program. At the end of the 6 weeks course, the reading speed of each student was measured. The results are summarized below. So you have the standard method and the new program. And you can see both have sample sizes of 50. Looks like the standard method's a little lower than the new program, a little more spread too. All right, so test an appropriate hypothesis to determine if there's convincing evidence that the true mean reading speed for high school seniors like these instructed by the standard method is different from the true mean reading speed for high school seniors like these instructed by the new program. And then I'm going to ask you, there's some questions, we'll hit these at the end, about type 1 or type 2 error. So, first of all, we want state. We want to test that the mean for the standard method minus the mean for the new program, is that equal to 0? So that's our null hypothesis. Our alternate, because it just says is different, that means we used not equals. All right, so this is a two-sided test. Then I properly defined both means. Make sure you do that. So the true mean reading speed for high school seniors, similar to those in this study. By the way, the reason I said similar to those to this study is we have volunteers here. So we have to just assume who would volunteer for a speed reading program, right? So make sure when you're doing experiments, and this is an experiment, that you say similar to those in this study, all right? Now, plan. We're going to do a two-sample t-test for those two means of the standard method minus mean of the new program. Random. Subjects were randomly assigned to the two treatment groups, standard method, new program. If it's representative, this condition is met. So actually, this condition is met. It's an experiment. So we just have to make sure that we're, say, similar to those in the study, okay? Now, if these seniors were representative of all high school seniors, then we could say, oh, I wouldn't have to say similar to those in this study. Okay, 10%. It's an experiment, so the 10% condition does not apply, all right? Is our sample big enough? Yes, in this case, we don't have to do any sketches or anything or look for outliers or skew because our sample is at least 30. All right. Then we have, so again, that's what you check if our sample size was less than 30. We did that actually on the last quiz review. Okay, next we can actually do the by hand method. We can actually go and calculate the standardized test statistic. So it's the difference in means over the standard deviation for the difference in means. So notice that has a plus, not a minus, because we always add on our variances before we take the square root. Now, that said, and then once we get our test statistics, since we're looking at different, we would do normal CDF for one of the edges and double it. That's why there's a 2 there. But it's way easier to do this with a calculator, and you're allowed. So here we go. So to do the hypothesis test on the calculator, we're going to hit Stat, go to Test, and we're doing two samples, and we are doing a t-test. So, oh, skipped right by it, number 4. Okay, so by the way, this is different from, it's got some old data, so let's make sure we put in the stats. So the mean for our sample is 445.8. Our standard deviation is 70.2. Sample size is 50. Our mean for the second sample is 463.2. And then we've got 66.6, sample size of 50. Our alternate hypothesis is not equal, so we're going to keep that. We're doing a two-sided test. And we hit calculate. All right. And so you can see there's our test statistic, negative 1.27. Our p-value is 0.2066. And our degrees of freedom is 97.73. One cool thing, and I didn't mention it on these tests, if you do a two-samp t-test, another option Not required, but if you're looking for a picture, it's very cool. So instead of hitting calculate down here, you can actually hit draw. You can also do this with normal CDF. And it shows you a picture. 2SAMP t-test, there's your test statistic and your p-value. The only thing this is missing is the degrees of freedom. So you want to be sure to include those three things in this part of the problem. So there's our calculator, what we input. Make sure you don't jump in the pool and give me these three things. This is what I need to see. I don't technically need to see the calculator speak, but if you mess up here, I might be able to give you partial credit. So I don't want to discourage handwork or showing me work, but be careful when you do it. Make sure you're doing the right work. All right. Conclude, because our p-value, 0.2066, is greater than our alpha 0.05, we fail to reject H0. Remember, the first sentence is always about the null hypothesis. Then the second sentence is about the strength of evidence for the alternate. Well, we fail to reject, so we do not have convincing evidence that the true mean reading speed for high school seniors like these instructed by the standard method is different from the true mean reading speed for high school seniors like these instructed by the new program. Okay, so assuming that the true mean reading speed for high school seniors like these instructed by the standard method is the same. Oh, I left out part B. Well, hold on, part A. Test an appropriate hypothesis. I did that. Oh, so this is actually, I'm like, what am I doing here? Here I'm interpreting the p-value. So sometimes you might be asked to interpret it. I really didn't ask it on this question, but let's go over the interpretation. What is 0.2066? Because that's one of the things that you struggle with is what the heck is a p-value? All right. Well, if the true mean reading speed was the same for both programs, the probability of getting a sample this or more extreme is 0.2066. So it's not that unlikely. So that's why we fail to reject. Okay, now going on to part B. Let's say the true mean difference. I unveil the curtain and I tell you, the truth is, it's really 0. It's exactly the same. Did a type 1 or type 2 error occur as a result of your hypothesis test? Well, that means the null is true. Did we stay with our null? We did because of our high p-value, right? So we failed to reject. In this particular case, we did not make a type 1 error since we retained H0. No error was made. By the way, never say except H0. And I've been trying to mark your test and your quizzes. If you say except, I ding you. That's a big statistical no-no. No, you can only make type 1 errors when the null is true, and that would happen when and you have a low p-value. So you have to have the instance that the null is true and a low p-value. Otherwise, you should not have a type 1 error. Okay, now we say, hey, the difference is really 8. All right. Did a type 1 or type 2 error occur? Well, the only error we could have made is type 2 because the second hypothesis is true. All right. Our p-value is 0.2066, so it's greater than alpha. We failed to reject H0. We're still there. So we still believe that the programs are the same, but in reality, they're different. So we made an error, not due to bad math or statistics, just unlucky samples. So again, type 2 error only occurs for high p-values when your alternate is true.